What is up, guys? We are back with another video on data structures and algorithm. Today the topic that we are going to discuss today is trees, right? So before we start with the operations or the traversal, let's have a little bit idea of what are trees. Okay, so trees are hierarchical structures that we can have in our computer systems, right? And this is a typical tree that we are having, right? Now, based on number of children, based on the maximum number of children a node can have, the trees are divided. Trees are basically classified into different types. Okay, so if the number of children, the maximum number of children of a tree are two, sorry, the maximum number of children of a node in a tree are 2, then we call it a binary tree, right? Then we call it a binary tree. If the maximum number of children is 3, then we call it a trinary tree, right? And similarly, if the maximum number of children a node can have is n, right, basically it is user defined, then we call that particular tree as n-nary tree, right? Okay, so when we are dealing with our usual computer science and computer algorithms, the type of tree that we will be use is binary tree. And let's have a visual diagram of a binary tree. How can you visualize a binary tree in a computer structure? So basically, a node of a binary tree, a node of a binary tree can be represented using this particular diagram. This is one node in which one side has left pointer, other side has right pointer, and in the middle we have data, right? So there are number of nodes. There are number of nodes depending on the size of the tree that we can have in our tree structure. So basically, left pointer points to the node, to the left node, right? And right pointers point to the similar right node, right? So this is the type of structure that we have when we are talking about trees and data structures. Okay, now let's discuss about the first operation that we can have on the trees. And the first thing that we do in any data structure that we can have is traversal, right? Because traversal is important here. What is the point of storing a data if you cannot retrieve it efficiently when required, right? So similarly, when we are talking about arrays, right, and we have to do the traversal to find any basically to see what is the data present in our array, the first thing that we do is linear traversals, where we extend where we explore every element from index 0 to index n-1, right? So similarly, in trees we have different traversal algorithms. Majorly there are two types of traversal in trees. First is breadth first search and second is depth first search. Okay, now as the name suggests, there are two different types of traversal techniques. In breadth first, what we have is, suppose this is the tree that we are having, right? Suppose this is the tree that we are having. In breadth first, our goal is to explore the levels, right? So basically, if this is the node, then we will explore its left, then its right, then we will explore the left child of this, then right, then left of this, then right. Okay, so basically we are exploring breadth wise, we are expanding breadth wise. In contrast to this breadth first search, in depth first search we have what we do, instead of going with this breadth first search approach, we go to the depth of first of a particular path, then we come back to the root. So for example, if this is the route that we are exploring, then we will go to the left part, right? And now before going to the right, we will go to the left of left, right? As long as lefts are present, we will go to till the left, then we will come back to the last collar, then go to the right of it, right? then come back to the last collar, then go to the right of it. So basically we are going in the depth of first part, then coming back to the main collar. So this is the approach that we have when we are talking about depth first search. Now in any of these traversal techniques, there are three main operations that we are doing, right? Three main operations that we do when we are traversing. Three main operations. First operation is explore the route, right? Suppose this is the binary tree that we are dealing with. Second operation is explore the left, and third is explore the right. So these are the three operations that we have when we are talking about traversing a binary tree. And basically it is the combination of these three operations only. It is the combination of these three operations only which results in different types of traversal techniques that we have, right? So from simple mathematics, three operations are there. Okay, so we can have 3 factorial ways to traverse a tree, and out of these 3 factorial, that is 6 ways, there are 3 very popular ways to traverse a binary tree, and they are in order. They are referred to as in order. Then we have pre-order, and then we have post-order, right? So let's discuss about that. Orders of traversal, right? And currently we are talking about depth first, right? Breadth first we will discuss after this depth first is over. Okay, so the first we have is in order, second we have is pre-order, and then we have is post order. Now there is one thing that you have to note is there are 6 ways, right, to apply these operation. We have taken all those three ways basically, in which left is explored before we explore the right. We are always exploring left before we are exploring the right. Okay, now to understand what is the order of the operations in all order of these operations in all these traversals, we will focus on the first part of this what is written. Okay, so first we have in, then we have pre, then we have post. And also there one rule is left is always explored before. So this particular part tells us the position of the route when our route will be explored. So in says that route will be between left and right, left and right. Pre says route is explored before left, before this happens, right? So route is explored before anything happens, right? So this is the order. And post says route is explored after this is explored. So we have left, then we have right, and then we have route. So these are the 3 major traversal orders of depth first search. Now this was a very basic video, and there is nothing much, there is nothing new. Basically if you have studied data structure, then this is a very basic knowledge to have. Now we just got it out of the way, and from the next video we will discuss in order traversal in detail, right?